Good day once again. On Monday, on the 8th of June 2020, we are able to cover definition, introduction, oxidation reduction reactions, introduction to oxidation reduction reactions, and the definition of oxidation based on addition and removal of oxygen, and also based on removal of hydrogen and addition of hydrogen. Now the third one is oxidation and reduction in terms of electron transfer. Oxidation reduction in terms of electron transfer. Oxidation is loss of electrons, while reduction is gain of electrons. Look at the example. We have magnesium metal and water molecule to form magnesium oxide and hydrogen gas. From this equation, oxidation state of hydrogen magnesium here is 0, and coming to this magnesium oxide, magnesium will lose its 2 electrons to oxygen, so that the oxidation state of magnesium will be +2. So you realize that in this compound, magnesium will transfer 2 of its electrons to oxygen. That is the transfer of oxygen. That is the transfer of electrons. And if from the definition, oxidation is loss of electrons, if magnesium loses its electrons to oxygen, it is known as oxidation. Then the water molecule, from this compound, we have oxygen and hydrogen. In this compound, hydrogen is proton. It is hydrogen proton because it's more electropositive than oxygen. Since oxygen is more electronegative, if they combine, this hydrogen will give it 2 electrons to oxygen, so that hydrogen will remain protons. But because magnesium is highly electropositive than this hydrogen, if they combine, magnesium will now displace this hydrogen, so that it will combine with this oxygen. But if this hydrogen is going, oxygen must give this hydrogen its electron that has been given before. So coming to this place, you now have your hydrogen gas. This hydrogen gas now has regained its electrons. So reduction is gain of electrons. From this, hydrogen does not have any electrons. It only has a proton. But coming here, it has both electrons and proton, gain of electrons. Since chemical reactions often involve the rearrangement of the outermost shell electrons of reacting species, they either transfer or they share electrons in order to gain higher stability. So you can see that in magnesium oxide, magnesium has lost 2 of its electrons to oxygen, hence it is oxidation. While in water molecule, in H2O molecule, because hydrogen is more electropositive than oxygen, it gave its electrons to oxygen. But when magnesium reacted with water molecule, as oxygen was leaving, it gave hydrogen its electrons. So on the product side, hydrogen has gained its electrons to form hydrogen gas. It was hydrogen proton, but now hydrogen gas. Magnesium is oxidized. Magnesium is oxidized, water molecule being an oxidizing agent. If magnesium is oxidized, water molecule is the oxidizing agent. And hydrogen is reduced, magnesium being a reducing agent. Now the fourth one, the last definition of oxidation is oxidation and reduction in terms of oxidation number. Oxidation is increase in oxidation number, while reduction is decrease in oxidation number. Oxidation number of magnesium in this state is 0, and here is +2. It has increased from plus it has increased from 0 to 2, hence is oxidation. While this one, hydrogen here is +1, coming to this place is 0. It has reduced from +1 to 0, hence is reduction. The summary of oxidizing and reducing agent. Oxidizing agent. An oxidizing agent, that is an oxidant or oxidizer, is an electron acceptor. That means there must be elements on the non-metals. They must be non-metals since they are electron acceptor. Number 2, an oxidizing agent gets reduced to a lower oxidation number in a redox reactions. Yes, because they will take an electrons. If they take electron from others, they get reduced. And generally, elements that are diatomic and in group 6 and 7 in the periodic table are oxidizing agents. Examples of oxidizing agents are oxygen, fluorine, chlorine, bromine, and others. Now, the reducing agent, a reducing agent, that is a reductant or reducer, is an electron donor. A reducing agent gets oxidized to a higher oxidation number in a redox reactions. That means if they give the electrons, the oxidation number will increase. Generally, elements, especially metals in group 1, group 2 and 3 in the periodic table are reducing agent, because if they give the electrons, those ones that receive the electron will be reduced, while those of them that give the electrons will be oxidized. Oxidation number will increase. For your assignment, for your information, practical on oxidation reduction, that is redox titration, will commence as soon as school reopen. So this is the end of the definitions of oxidation reductions. You will be given assignment in the Google class. Make sure you solve your assignment perfectly with the given examples. Make sure you do your assignment perfectly. You can now read ahead on balancing redox equation by half reactions for next week. Thank you. And whenever you are confused, please don't hesitate to contact me through WhatsApp. Either you post it or you use voice record. I will respond to your request. I am waiting to hear from you. Thank you and goodbye.